Hey fellas, what is up? Welcome to the daily lead code challenge for today. Today the problem is minimum moves to equal array elements. So let's understand what the problem actually says and let's straight away dive into that. So the problem statement says that you're given an array. Let's say the array is 1, 2, and 3. You have to make all the elements equal in minimum number of moves, right? So just to say, what you have to do is like if you make all the elements of this array as 1. So the move would be the first element is already 1. The second element would have to subtract the 1 from it to make it a 1. So this counts as one move. Like this one deletion is one move, right? So this is 1 and the total number of moves is equals to 1. And for 3, you have to make such 2 moves of subtracting 1. So this is one move and this is the second move. So it becomes 1. And hence the total number of moves becomes 1 plus 2 is equals to 3. Right, and we have to minimize these number of moves, right? So what we can do is let's take another example. Say we are given the same array, and now what we'll do is we'll make everything equal to 2, right? So to make 1 equal to 2, what we have to do is 1 plus 1 is equals to 2. So one operation means one move. So the move count right now is 1. 2 is already 2, right? So we have 2 comma 2. This consumes one move, right? Now to make 3 equal to 2, what we have to do is we have to subtract 1. That is one move. So 2. So one move. So we get a total of 2 moves. So the minimum number of moves to make all the elements equal is 2 moves. And what is that element? That element is 2, right? Now, here's another array. If I directly look at the question, I cannot think of any algorithm or any technique to actually implement to do this in minimum possible complexity, right? But one intuition that I have is, let's say, I believe if all the numbers were to be converted to the minimum number, here the minimum number is 1, then the cost of operation for converting the maximum number, which is 9, to the minimum would be the maximum number is 10. So the cost of operation to convert the maximum number to the minimum number would be very costly, right? Similarly, if you convert all the numbers to the maximum number, then the cost of operation of converting the minimum number to the maximum number would be very high, right? So what I would like to think about is intuitive. So what I would like to think about with my intuition is that the number should lie somewhere in between, right? So let's do one thing. Let's first sort the array. The first thing I would do is sort the array. Sort. So after sorting, the array becomes 1, 2, 9, and 10. Right, I've sorted the array. Now, if I look closely, in the first example, what I did is I took the median element and converted all the elements to that element, to the median element. Now, if you don't know what the median element is the middle element of any array. So the middle element of an odd array, you have a median element. But say if you have an even number array, which means you have even number of elements, then the median element could be 2 over here. I'm taking 2 as a median element. So let's see what's the cost of converting everything to 2 over here. So the cost for this would be plus 1. The cost for this would be 0. The cost for this would be 7. And the cost for this would be 8. So this would be 8, 7, 15, and 16. So let's now look at what would be the cost to actually convert all the elements to 9, right? So for the first element, it would be 8. For the second, it would be 7. For 9, it would be 0. And for 10, it would be 1. So this is also 16. So I'm noticing that either I could take this element or this element. It is not mattering right now. Once we go, we'll check if we get some error, some test cases not accepted, then we'll try to check and try to define a median by 2 plus 9, which is, I don't think it would work for this case. Another intuition that I would like to give you to better understand this problem rather than this way is, imagine you have few friends, right? And they live in the same colony. They live in the same street. And here are the indexes of their places. So say the first person lives at 5. The second person lives as 10, this is x, right? And this is some distance x, this is starting point, this is 0. The third person lives at 15 and the fourth person lives at 20. Then you have 35, right? Now they all decide, it's Saturday evening and they all decide they need to meet to maybe have fun or something, right? Here nobody lives. The first person lives here, the second here, the third here, the fourth here, the fifth here. So they decide that they want to meet. Now the question arises is they want to meet in such a way that all of them combinedly, when they have to travel to someone's home, the total distance that they have to cover would be minimum, which is the direct translation of actually this problem over here. So say if all of them decide to meet at the home of the second person who lives at the x coordinate of 10, so the first person would have to go 5 distance forward, right? The second person is already at home, he has to go 0. The third person has to go 5. The fourth person actually has to go 10. And the fifth person actually has to go 15. So that sums up to 20, 30, and that's 35. Right. This is the cost for combined cost for all of them. Now, let's say they decide to meet at the home of the third person. So the first person has to actually go 10. The second person actually has to go 5. The third person doesn't has to move an inch. The fourth person has to go 5, and the fifth person has to go 10. So 10, 15, 20, and 30. So the total cost is 30, which is actually minimum than if they decide to meet at the second person's place. So if you again look at this problem as an array, you have 5 elements over here, and if you decide to meet at the median of the array, the total cost would always be the minimum. So let's take up this principle and let's try and solve this problem. Let's move on to the code part. So we are here at the code part. Now let's start coding the problem. So the first thing first, I would like to sort the array. So it would be num start key is equals to lambda. After that, once I have the sorted array, what I'll do is my starting index would be 0, my ending index would be length of nums minus 1. So if say my array is of, I would say, odd length divided by 2 equals to 1, then I know there's just one median element over there, right, which is the middle element, right? So in this example here, 1 2 3, if you have 1 2 3, then 2 is the middle element. So what I would do is I would just, so if I have an odd length array, then I know the middle element would be, the median would be I plus j, and then you have divided by 2. Otherwise, the median element, if I have an even array, it would be, I would say I median is equals to I plus j divided by 2, and then we change it into an integer. So if it's 1.4, it gets to 1, right? Now, let's initialize a variable to count the distance that every number has to move. So let's call it distance, and its initial value is 0. So for I in nums, distance plus is equals to the middle element, because you want to travel until the middle element, so it would be absolute value of nums median minus the element we are currently at. So then you simply have to return the distance, and that would be all. So let's check. Yep, let's try submitting this. Yeah, so it got accepted. So this is the whole concept behind this, and I think taking the intuition from the friends thing is the best possible way to think about this problem. So that's it for today, guys. I'll see you tomorrow with another problem of the Leetcode daily challenge.